Okay, number 15 of the chapter 4 review packet. Let g be the function defined by g of x equals x to the fourth for x less than or equal to 0, and negative x squared for x greater than 0. If you look at the question, it's asking about, it's a multiple choice question with several options here. Which of the following statements about g is true? G is discontinuous at x equals 0. G prime of 0 does not exist. G prime of x is less than 0 for x not equal to 0. G double prime of x is less than 0 for all x. Or G has a relative maximum. We need to know which of those are true. So first of all, we can check to see if G is discontinuous by simply plugging 0 in to both parts of the equation. If you plug 0 into both of these, what do you get? 0, 0. That tells me that the two graphs come together. The left part of the graph and the right part of the graph both come together at the point 0, 0. So A is not true. A says G is discontinuous at x equals 0. That's not true. The two graphs are going to meet. It's going to be continuous at x equals 0. Part B is about the first derivative, so let's find that next. So the derivative of x to the fourth would be 4x cubed. That's for x less than 0. And the derivative of negative x squared would be negative 2x. That's for x greater than 0. Notice I did not put an equal bar under the 0 because I'm not sure if there is a derivative at 0 or not. Here's how we're going to find out. We're going to find the left-hand derivative at 0 and the right-hand derivative at 0 by just plugging 0 into both of these expressions. What do you get if you plug 0 into both of those expressions? 0. So the left-hand derivative equals 0 and the right-hand derivative equals 0. That means on the graph of g of x, the slope is approaching 0 from both sides. It's going to be a nice smooth curve there. So g prime of 0 does exist. G prime of 0 would equal 0. Because if you plug 0 into both equations, you get 0. So B is also false. Part C, g prime of x is less than 0 when x is not equal to 0. Let's check that out by making a number line chart. Let's, 0 is kind of a special number because that's where we switch domains. I can put an equal bar there now since I found that answer. If you put a number in smaller than 0 into the derivative, like a negative 4, what type of answer would you get? Negative. If you put an answer in bigger than 0, like 2, it would go in the bottom equation. Put a 2 in here, what would you get? Negative. So it looks like the first derivative is negative at all values except x equals 0. So part C would be true. The next part D asks for g double prime. Let's do g double prime. So the derivative of 4x cubed would be 12x squared. When x is less than or equal to 0, let's just put less than 0 because I'm not sure if the derivative exists at, if the second derivative exists at 0 or not yet. Derivative of negative 2x is negative 2. Now plug 0 into both of these. Make another number line chart for the second derivative. If you plug 0 into the top expression, you get 0. Plug 0 into the top expression, it's just negative 2. So the left-hand second derivative and the right-hand second derivative at 0 give you two different answers. So what could I say about the second derivative at 0? It's undefined, yeah. If the left-hand second derivative and the right-hand second derivative are different answers, then there is no second derivative at 0, so there would be no equal bar here. Now pick a number smaller than 0, like negative 10, and plug it in the top expression and get a positive. Pick a number bigger than 0, plug it in the bottom expression, you get a negative. Part D says g double prime of x is less than 0 for all x. That's not true. G double prime of x is positive when x is less than 0. Okay, it's trying to say it's negative for all values of x, so D is not true. Last part, E, G has a relative maximum. Well, based on what I looked, by looking back at the first derivative chart, it's showing me that G decreases, then goes to a slope of 0, then decreases again. So, and it's going to go concave up, concave down. So it's going to go something like this: decreasing concave up, slope of 0, and then decreasing concave down. So does it have any relative extreme, any maxes or mins? No, it doesn't. So E is also false. Any questions about that one?